Hello everyone, welcome to our channel Melting Math. In this video, we are going to discuss about force and motion, which is in the 6th standard new syllabus term 1 book. These force and motions are happen most of the times in push or a pull of an object. Let's see some examples. First, we are unlocking the door by pushing the lock. Second, we are lifting the bag by pulling that bag. Third, we are kicking the ball by pushing that ball. So in these three things, this push and pull or makes the motion to move some object. So second one, motion and a rest. These two are a reversible process. Motion will occur after the rest will occur after the motion. Okay. Here, when there is a change of position of an object with respect to time, then it is called motion. If it remains stationary, then it's called rest. Stationary means it's rest only. Stationary means it remains rest. Okay. Here we already discussed some examples. Let's see that same one. Here, before unlocking the door, what is the state of the door? It's in rest only. So it's rest. Second image, before we lifting that bag, what is the state of the bag? It's also in rest only. Third, if before kicking that ball, what is the state of the ball? That's also in rest only. So this motion and rest are a reversible process. One occurs, then another. Okay, these are spontaneous process. Next, observe these images. See, first one. Here, one girl pulling the bucket to fetch the water. So here, pull is the answer. Next one, the shopkeeper pushes the vehicle to move forward. Here, push is the answer. Next one, the boy pushes the wheel to move forward. Here also push is the answer. Next one, the boy pushes the swing to move forward. Here also the push is the answer. Next one, the man pulled the bullock cart rope to stop the vehicle. Here, pull is the answer. Next one, here they are pushing the hammer to insert the nail. So push is the answer. Okay, next one, observe this image. One man moving on the boat with respect to the surroundings, but he is in rest with respect to the boat. Okay, then observe the second image. The girl on the swing is dashed with respect to seat of the swing. She is moving with respect to the seat of the swing. Then she is dashed with respect to the garden. She is at rest with respect to the garden. Okay, these are the answers. Suppose the man is dancing on the boat means the state of the man with respect to the boat is moving. Okay, now in this picture, he is simply sitting on the boat. That's why we are mentioning here the man is at rest with respect to the boat. Okay, have you all clear about this? Okay. Next, observe this image. One girl is moving on the road with the use of bicycle. Okay, just answer this. Nisha is going to her grandma's house by bicycle. The girl on the bicycle is dashed with respect to the road. With respect to the road, Nisha is moving. Okay, Nisha is moving with respect to the road, but with respect to the cycle, she is at rest. Okay, these are the answers. Next, how the things move. We already discussed this. Things move with a push or a pull of an object. Okay, here they are mentioning motions occurs when the object is pulled or pushed by an agency. That's we already discussed. Push or a pull of an object. That's that they are mentioning here. Second, force or push or pull by an animated or inanimated agencies. These are very important. Here they are mentioning animated means a contact force. Inanimated means it's a non-contact force. Contact force is what? That's animated force. We are the source to push the object. If a non-contact mode, that's inanimated means that's a natural thing. It's gravitation. Suppose we are swinging on the tree means that's a contact force. We are pulling the bag means that's a contact force because we are pulling that. Okay, suppose for a non-contact force, inanimated force, that's can happen in the naturally. See here, when the coconut downs on the earth, because that's due to the gravity, because that's not an contact force. Okay, have you all clear about this? Okay, next, fill in the empty spaces. See, in center they gave force can. See the left side, force can move from rest, force can change the speed. So what is the third one? Force can change the speed and change the shape also, because we are bending the steel and all by using the force only. So force can change the shape. Okay, next right side, force can compress or expand. Okay, force can compress or expand. Force can, see here we saw move from rest, here rest to move. Force can rest to move. I already told in the beginning, it's rest to move, move to rest. That's the main common thing. It's a reversible process. Okay, next second one, change shape, here change direction. Force can change the direction. Okay, by we are going to the in a car or bicycle, we used to turn by using the force only. Okay, force can change the direction also. So okay, second one, can you give example for contact and non-contact force? Okay, force, here they one side they gave contact force, on other side they gave non-contact force. See the example, one example they gave already, kick a football. Okay, first one they gave, second one we asked the answer from us. Okay, what is the answer? Someone guess. The man stopped the bullet cart by pulling it. Okay, it's a contact force, we are pulling it. By we are lifting the bag is also a non-contact force. You can write anything whatever, because contact force is from more from our surroundings, because all the things in our surroundings are using the contact force only. Non-contact force are very rare. It's like a coconut falls on a ground. That's the main thing. So here the second one's example, non-contact force example is coconut falls on ground. Okay, next they are classified the motion based on a three parts. Okay, based on path, based on duration, based on speed. Let's see the based on path. Based on path, they splitted linear motion, curvilinear motion, circular motion, rotatory motion, oscillatory motion, zigzag or irregular motion. Based on the duration, they splitted periodic motion, non-periodic motion. Based on the speed, they splitted uniform and non-uniform motion. Upcoming, we are discussing this in briefly. Okay, based on path, let's see. Linear motion. First one, linear motion, moving in a straight line like a person walking on a straight path, free fall. It's like if we are going in a car with a constant speed and the straight line, means that's also the linear motion. That's a very good example for a linear motion. Second one is a curvilinear motion, moving ahead by changing direction like a throwing ball. If we throw a ball, that after the pitching the ball, the direction will change. That's they are mentioning here. After the ball, the changing of the direction is here. They are mentioning the curvilinear. So it's a curvilinear motion. Next one, circular motion, moving in a circle, swirling stone tied to the rope. They are giving the example is this, but circular motion in our surroundings also so many examples are there. The best example is our fan. It's a circular motion. It's fixed at a one point and rotate itself. So it's a circular motion. Fan is also a good example for a circular motion. Second one is a rotatory motion, the movement of a body about its own axis like a rotating top. It's a rotating top here. It's a cycle wheel. These are all a rotatory motion. It's rotate on its own axis. It's not depend on any particular at all. Just see, circular is a fixed. It's rotating at a fixed point. It's rotating a circle at a fixed point, but rotatory is it's rotating along with this object. That's the rotatory motion. Okay, next oscillatory motion, coming back to the same position after a fixed time interval like a pendulum. So pendulum is a very good example for the oscillatory motion, because when we swing that pendulum, after some time it will reach that same that position that they are mentioning here. So pendulum is a very good example for oscillatory motion. Also one good example is there for oscillatory motion. That's when we are swinging the rubber band, by stretching the rubber band from one side to another side. If you string it at the center, that rubber band will vibrate. That's also the best example for a oscillatory motion. Next one is a zigzag, like a motion of a bee or a people walking in a crowd street. Now, people walking in the crowd street is also a very good example. But when a car moves in a zigzag manner, like a cross manner, it's also involved in this type of motion. Okay. Next, see here they are given some pictures from based on the bee. Let's guess which type of motion occurs in the each diagram. Let's see, first one they gave linear motion, second one is in curve form, so it's a curvilinear motion. Second one is rotating self in a round manner, so it's a circular motion. Third one it's moving in a zigzag manner, see here, so it's a zigzag motion. Fourth one, B goes here to there in the same direction. That's why they are mentioning that arrow mark here and there. So it's an oscillatory motion. Okay, that's why they are mentioning that arrow mark here to there. So it's an oscillatory motion. Next other classification of motion is a periodic and non-periodic motion. Let's see, motion repeated in equal interval of time is called a periodic motion. It's repeated in equal motion of a time. Let's see, let's guess what's a good example for this periodic motion is a pendulum. Pendulum is a very good example because it reaches its same position after a period of some time. So that's a periodic time. We can calculate its time duration. That's we are mentioning here the periodic motion. So second one, non-periodic motion. We cannot calculate the period of a motion. That's the non-periodic motion. Let's see. Let us take an example of tree swinging in a wind. If a tree swing in a wind, we can't calculate how many time it's swing, how much the hair is coming, because the swinging is differ from the wind, so it's not a constant value, so we cannot calculate this value and all. So that's why we are mentioning these are a non-periodic motion. So this only they are mentioning this motion is not in uniform interval. So for the pendulum we can calculate because it's in uniform only, it's go here to there. Okay, there is no external force on that. That's based on that bomb only, it's moving. For the non-periodic motion we cannot calculate anymore. Okay, that's the main difference between this periodic and non-periodic motion. Next, see this image, we have to find the average speed. Here first see, taxi travels 160 km in 2 hours, bus traveled 200 km in 4 hours, and a truck traveled 300 km in 5 hours. Here we have to find which vehicle is going fast and which vehicle is going slow speed. For finding it, we have to find the average speed of each vehicle. For that, one formula is there. Average speed is equal to time distance traveled divided by time taken. For first taxi, the time taken is 160 km. Distance traveled is 160 km, and the time taken is 2 hours. So 160 divided by 2, we get 80 km. Next, for bus, distance traveled is 200 km and the time taken is 4 hours. So 200 divided by 4, we can get 50 km. So the speed of a bus in an hour is 50 km. Next, taxi, traveled distance is 300 km. Distance covered is 300 km and time taken is 5 hours. So 300 divided by 5, we get 60 km per hour. So by comparing these three, we get the faster vehicle is 80 km, that's car, and the slowest vehicle is bus, that's 50 km. We can find it by using this formula. Just understood this formula. Average speed is equal to distance traveled divided by time taken. Distance traveled is nothing but the distance taken by the vehicle to reach or travel, that they think. The time is nothing but the time taken by the vehicle to reach the place that they are mentioning here. So this formula is very important. Average speed is equal to distance traveled covered divided by time taken. Next, they gave some questions to calculate us. So let's find the answer for these questions. First one, a cat traveled 150 meters in 10 seconds. What is its average speed? If they are asking the average speed means first we get the knowledge of that formula. Average speed is equal to distance covered divided by time taken. So see this question. First, distance covered. How many distance is this cat is covered? 150 meters. So distance covered is 150 meter. Divided by time taken is they are mentioning 10 seconds. So 10 seconds. By dividing it, we get 15 meter per second. These units are very, very important. So distance covered is 150 meter and the time taken is 10 seconds. This meter and seconds are very important. That's why we gave m divided by s is we mentioned here meter by second. By cancelling the 150 divided by 10, we get 15 meter per second. So average speed of that cat travel is 15 meter per second. Okay, let's see the second one. Priya ride her bicycle 40 kilometer in 2 hours. What is her average speed? So here also see in this question they ask the average speed. So we get the formula. Average speed is equal to distance covered divided by time taken. So they mentioned here distance covered of the bicycle is 40 kilometer and the time taken is 2 hours. By dividing it these two we get 20 kilometer per hour. These two units are very important. I already mentioned these units are very important. Kilometer per hour, how we mentioned this kilometer per hour is distance covered is they in that question also they mentioned distance covered is kilometer, 40 kilometer, time taken is 2 hours. Its unit is hour. In previous question they mentioned distance covered in meters, so that's 150 meter and the time taken is 10 second. They are mentioning it in second. So these two units are very important for answers in your exams. Teachers should ask the units, then only they will give the full mark for this question and all. Next, speed equal to distance traveled divided by time taken. We denoted it as s equal to d divided by t. In this s equal to d divided by d, we can derive another formula also. S into t equal to d, that's speed into time equal to distance. From this also we can derive another formula. That's t equal to d divided by s, that's time equal to distance divided by second. Let's see one example. If they gave second equal to 50 km per hour and time equal to 5 hour, from these which formula is suitable for us? That's second speed into time equal to distance, that's suitable for this. So distance equal to speed they gave 50 and the time is 5, so 50 into 5 equal to 250 kilometer. From that unit, kilometer per hour into hour, that hour will cancel and the kilometer will remain the same. So for the answer 250 kilometer. Next, compute the following numerical problems. First question, if you travel 10 kilometers in 2 hours, your speed is dash kilometer per hour. If you travel 10 kilometers in 2 hours means what? Here the kilometer, 10 kilometer is the distance. So distance divided by, they gave a time, that's speed. We have to find the speed. So distance divided by time is a formula. So 10 divided by 2 is 5. So 5 kilometer per hour. That's the answer for this question. Second one, if you travel 15 kilometers in half an hour, you would travel dash kilometer in 1 hour. See here, half an hour will reach a 15 kilometer, means for 1 hour will reach 30 kilometers. Just multiply the kilometer into 2. 15 into 2 we get 30 kilometer. So 30 kilometers and your speed is dash kilometer per hour. We already know. See the previous answer. You would travel 30 kilometer in 1 hour. That's the answer is there itself. So our speed is 30 kilometer per hour. So next, third one, if you run fast at 20 kilometers per hour for 2 hours, you will cover dash kilometer. Just see, for 2 hours we are reaching a 20 kilometers per hour. Per hour we are reaching 20 kilometers. For 2 hours, how much kilometer we reach? Just multiply into 2 with a kilometer. 20 into 2, 40 kilometers. So the answer is a 40 kilometer. Next one, uniform and a non-uniform motion. Let's see the uniform motion. When a car moves on the straight road with a constant speed, that's known as uniform motion. For a non-uniform motion, when a car move at a rest and moves with a various speed and reaches someplace, that's a non-uniform motion. Okay, for a uniform motion, the car moving with the same speed. For a non-uniform motion, the car moving with a different speed. Okay, that's the main difference between uniform and a non-uniform motion. Next, multiple motion. Let's observe this image here. From the bicycle, from this wheel acts as a two motion. One is a rotatory motion, another one is a linear motion. By rotating the wheel, it shows the rotatory motion. By moving towards that's in that they are mentioning the linear motion. Let's next observe this image and answer it. Motion of a needle. What is the motion of a needle? Needle will goes up and down. That's a which motion? It's a periodic or oscillatory motion. Next, motion of a wheel is what? Motion of a wheel is what? Is always rotatory motion. Wheel is rotating in that swing machine. So motion of a wheel is rotatory motion. It's the answer. Next, motion of the foot rest for that swing machine. For foot rest, we are pressuring that foot rest in up and down manner. So it's an oscillatory motion. Okay. Next, science today is robot. Robots are automatic machines. Robots are automatic machines. Nowadays, robots are used in markets, hotels to serve food for delivery purpose, and all robots are using nowadays. Robotics is a science and a study of robots. Robots can do work much more better than the human. Okay, next see what can robot do. Nowadays, robots assemble the spare parts of the cars and the operations. Nowadays robots doing the operation for some small operation for human beings and all. So robot can do some much more big process when compared to men. Okay, how do robots sense? Robots sense using the electronic sensors. Okay, by robots can identify uh, voice by using the microphone. Robots can identify the sense of touch by using the pressure sensor. Robot can hear, see by using the electronic sensors. Robot can see by using the twin video camera options. So these are the robot sensory organs. Okay, next see artificial intelligence. Yeah, in artificial intelligence of robot is we are inserting the human behavior manner to that robot to behave like a human, to speak like a human. So we inject that human behavior manner and all. That's artificial intelligence. Robot can think. Yes, robot can think by the manual programming. For if you're seeing in a computer and all, the computer can play chess with us. That's the robot thinking only. We are setting that type of manner in that robot program. That's why robot can think. You already know that memory card and all are there for programming that robot. So that's it. Next, nanorobotics. Nanorobotics is mostly used in the medical field to diagnose the cancer, some cells, cancer cells, to destroy the cancer cells in the medical field. And it's in a very small shape. That's why we inject it in through our body for finding some cells, virus cells, for deleting virus cells and all. Okay, that's it. For the in the upcoming videos we can see the book back, that's the evaluation question and answer of this force and motion. Thank you. Subscribe to Melting Math channel and don't forget to press the bell icon. Thank you.